Hey guys, what is up? How's it going? Welcome back to another episode on Space Tour Live. We're back with the Space Roundup as we are every other Tuesday night, and we've got our space experts and astronomers in the house, Nick Howes and Terry Mosley. How are you guys doing tonight?
Hi, very well.
Pretty good. All things considered, yeah, pretty
Yeah.
good.
Indeed. Thank you so much for continuing to support Space Still Live. This show has gone from strength to strength. Our views continue to grow. Our channel continues to grow because of you, because of what you do. And we're also streaming on Twitter tonight. So if you're joining us on Twitter, thank you so much. Thanks to everyone joining us on YouTube as well and Facebook for taking the time out of your busy Tuesday evenings. Um, but strap in for another great show of the latest and greatest space news. I'll hand over to you guys. Have a good show.
Cheers, Latch.
Cheers.
Greatest show. I don't know. We're quite irreverent, and we do tell it how it is. Let's put it that way. We're not exactly the most PC people when it comes to the news, but no, it's a lot obviously happening in the world at the moment, and we're going to touch on that quite extensively with tonight's show because you can't really escape it. It's dominating the news. Obviously, what's happening in the Ukraine, etc. But we got a lot of positive stuff as well to talk about, especially that our massive friends at Space Store, the people who host this for us, they're partnering with Razer, who are like massively into STEM and outreach, and for Mars Week, because this week is Mars Week. So there's lots of activities being sponsored by the European Space Agency, by ESRO, all sorts of different organisations all over the world. In support of Mars Week. Obviously, we're going to be touching on some of the big stories from Mars that are happening at the moment. One place that doesn't seem to be being affected by events on this planet. But yeah, I'll let Latch tell you a bit more about that at the end of the show. But really fantastic stuff happening for Mars Week at the Space Store. So just wanted to say a big shout out to them again for this. And we'll kick off with, this is the first of our bad news stories, really. We're going to come to some good ones, trust me. But I'll hand over to Terry for this one. This is the now looking like absolute cancellation of Rosalind Franklin.
Yeah. I just want to say, as Nick was saying there, we will be discussing sensitive issues. So I just want to say anything I say in that respect will be my own personal views, not necessarily representing those of Space Store or any other associated organizations.
Absolutely. Yeah.
We'll try and be honest, but we'll try and be careful and sensitive and so on. So the Rosalind Franklin mission is part of the overall ExoMars mission, which is a joint Russian ESA mission to Mars. It's already got underway back in 2016. The first part of the mission was launched. The Trace Gas Orbiter is already in orbit around Mars and doing very useful work. The first part of the landing part of it, the Schiaparelli lander, unfortunately crashed on landing, so we never got anything back from that. But Trace Gas Orbiter is still there working. The next part of that was to be the launch of the Rosalind Franklin rover, which named after a very well-known American astronomer. And that was originally to launch in 2020. It was delayed for a number of reasons, some technical and some then because of the intervention of COVID. And it had been rearranged for a launch at the end of September this year. And now, unfortunately, because of what's happening in Ukraine, it's almost certainly postponed. It doesn't seem as if it's possible that that can launch this year. And that means, unfortunately, a delay of at least 2 years before we have another launch window. Now, we can only hope that somebody in Moscow sees sense and basically calls an end to the carnage and the slaughter in Ukraine. That's being very optimistic. There are all sorts of political and military angles on this, which I'm not going to go into. But if by some miracle the conflict was to stop in the next day or so, I still don't think it will be possible to resurrect the mission launch at the end of the month, partly because there'll probably still be sanctions applied to Russia, and partly because basically all the preparations between now and September have been put on hold. And if you miss the launch window by a week or so, you've lost it altogether until about 2 years later, when Earth and Mars come back to roughly the same relative positions. It's just under 2 years and 2 months that you get a repeat window. So it looks almost certain that it's not going to launch this September. And if that doesn't happen, then the next possibility would be 2 years and 2 months or so from now. Whether that will be an option or not, I simply don't know. I think we're into political issues here, just what the relationship between ESA and Russia will be after this conflict comes to an end, and it will have to come to an end eventually. I don't think it's going to be possible to resurrect a good working relationship. Certainly Roscosmos, the Russian space agency, are pretty displeased with what has happened in terms of Western sanctions and so on. And it could take a long time to rebuild bridges. The head of Roscosmos in particular has been very anti-American, very pro-Putin. So that's going to be a problem. He might possibly be replaced and somebody a bit more liberal might take over. That's obviously just conjecture. Even if that happens, I think it's going to be a case of we'll almost certainly miss this launch, which is an absolute shame. In the meantime, of course, things are happening in Mars, as we'll be talking about later. We just hope that the delay of the launch of the Rosalind Franklin rover won't be delayed so much that what is happening in Mars is basically going to fail, because we don't have the continuity to maintain all the samples and get them to, I'm getting out of the context of this one, but basically to the eventual sample return mission. It gets very, very complicated. Anyway, the good news is that the ESA are still hoping to go ahead with this. Just when it will happen and if it will happen remains to be seen, but it's an absolute shame. Of course, a space mission really pales into insignificance in terms of the tragedy that's happening in Ukraine, but we're not going into that. We're just looking at the space side of it. So eventually, as I say, the aim is to get a return sample mission from Mars with the samples that are being collected at the moment by Perseverance, and we'll come on to that later. The other angle in terms of the problem with the Russians at the moment is that the American astronaut Van der Hai, who actually is just today set new US space record of 355 days in space continually, not the overall record, which is held by Russian almost 100 days longer. He is due to return in a Soyuz spacecraft to Kazakhstan with 2 other Russian cosmonauts on the 30th of March. And if you've been watching the news, you're probably aware that the head of Roscosmos was threatening not to bring him back. And of course, Elon Musk said, well, no problem, we can do that. But anyway, this is sort of a thing where I think the headlines are probably worse than the reality. Roscosmos, I think, it's not just a one-man show. I think they will be realistic and say, yes, look, whatever's happening in Ukraine or elsewhere in the world, we get this guy down. He doesn't land in Russia. Fortunately, he lands in Kazakhstan. And the NASA will have a plane ready there as soon as he's out of the spacecraft and got to the airfield. They will whisk him back straight to America. He won't have to go via Russia. The other angle, again, is this head of Roscosmos. I'm not going to say any more about him. He's threatening that they will abandon the International Space Station and let it crash down. And he says, what happens if it crashes in America or China or India or anything? It's not just as simple as that. It would take quite a while for it to come down, and they cannot control just where it will come down. They just do not have that degree of control over it. And he says it doesn't fly over Russia. Well, actually, it does. It flies over the southern part of Russia. There are about 3 or 4 fairly big Russian cities that it flies over. So if it did make an uncontrolled re-entry, it could possibly land on Russia, but not very likely. The long-term future of the ISS is probably the greatest issue, because while the Americans want to, and the Europeans and the Japanese and the Canadians want to keep it going until 2030, Russia is only committed to keeping it going until 2024. And the way things are going at the moment, it doesn't look very likely that they will continue that beyond 2024, unless there's a complete change at the top in Moscow, both in terms of the president and the head of Roscosmos. So that's a sort of a brief summary of some of the issues and the problems that we have at the moment on the space sector. And Nick, I'm sure you have lots of views on it as well.
I have. I'm just picking up some of the chat thread, like Ground-Based Space, saying, the whole, it's true, the damage being caused to Roscosmos is quite significant. Dmitry Rogozin, who's the head of Roscosmos, it's almost like the guy's become slightly unhinged, and it's a real shame, as you said, because there's some brilliant scientists who are really desperately trying to salvage something from this. And I've got friends who work at companies like Airbus, etc., who spent years working on things like Rosalind Franklin, and they, their careers literally are being shot to pieces by this. And yes, you're completely right. Compared to the horrors that people are undergoing in Ukraine, this is really trivial stuff. But it was one example where humanity really was coming together. The joint exploration of space, going back to the Apollo Soyuz test project in 1975, which is realistically when the start of the collapse of the Berlin Wall happened. And the first time NASA and the Soviet Union, as then was, joined together in space and really shook hands and started to say, okay, we can collaborate. No matter what's happening on the Earth, we can collaborate. And talking to, again, friends, I've got a friend who's one of the ISS ground control team, and she'd said, 2 weeks ago, there are existing legal frameworks or existing protections in place to kind of salvage what's happening up there. And the currently, as we speak live right now, there's an EVA happening on the ISS. So it's not like everything's stopped up there, but you just don't know what to think of what Putin and or the likes of Dmitry Rogozin are going to do next. Going up to this story as well, and the whole Soyuz suspensions. Don't forget there are 16 commercial launches scheduled to fly on Soyuz in the next 2 years alone. And these are like payloads from companies like OneWeb. Now, OneWeb, the UK government has got a massive investment in this, $400-500 million investment in OneWeb to provide, a competitor, as it were, to Starlink. And we've had many discussions about this and how we dislike the mega constellations. But they've got those. You've got the European Commission, you've got the government of Sweden, you've got obviously Rosalind Franklin, which is the big one. And the other thing with Rosalind Franklin is that not just the Russian Proton rocket, which is launching it. And interestingly, even today, there was apparently a Telegram channel message from Dmitry Rogozin saying that they still wanted to launch it. So he's clearly still blowing hot and cold and has realized, I think, the impact of possibly his own actions on everything that's happening. And this is not going to happen. There's not going to be a flight. The PR disaster for the European Space Agency, were they to even consider taking up this offer, would be catastrophic. You only have to look at Shell, Coca-Cola, and everyone else. Anyone who's even hinted at remaining in contact with Russia in any way, shape, or form has been literally torn apart. And the whole threat of you literally not just cancelling an individual, but cancelling an entire company. The threat to these companies is so significant that they've all pretty much done the right thing and said we're having nothing to do with them. So that is good. Whether or not Rosalind Franklin will fly, I think it will depend on NASA coming back into it. NASA obviously left the European Space Agency in the lurch by pulling out of this program some years ago. And I think, we talked about this before, Adam Steltzner and Sky Crane, the Kazachok lander is not only instrumental to how this works. It was like how they were going to get down to the surface. And as you said, Schiaparelli, they'd had some problems before. And Russia have never, don't forget, successfully got anything onto the surface of Mars for more than about 16 seconds since the 1970s, when they managed to get something onto the surface, transmit a couple of lines, and that was about it. But as I said, it would be catastrophic. And the impact on the Soyuz launches, and don't forget, the Soyuz is one of the most reliable launch vehicles in the world. So the slack's going to have to be taken up. And Ariane 6 and the Vega rocket, and there's lots of options out there. But whether or not they can take up the slack, especially, commercial companies like OneWeb, this could really put them in serious jeopardy. So it's interesting, again, just kind of looking at the chat, and people like, again, Ground-Based Space saying very surprised that there wasn't a kind of contingency. And yes, and people have been following me on Twitter. I've been saying this for years. The reliance on a Proton rocket, especially given the Russians' lack of success on Mars, I always thought was a big risk. Anyway, never mind what's happening right now. So the contingency, I think this will be a big lesson for most of the space sector, in that we'll talk about this with Ingenuity and the use of commercial off-the-shelf technologies in later in the show. But I think there needs to be more flexibility, I think, now in terms of launch providers, fairing systems, fairing integration, etc. And I know there are companies looking at this. I know there are companies that are looking at almost as what they call Legoization of space, where you can almost use building blocks from different systems and integrate them together. That, I think, is going to be probably the way forward, I think, from this, because so much money's been lost in space exploration, so much science has been lost, and that's the real tragedy. It's not the money can be recouped, etc. Lives are lost. You can't recoup lives, and you can't recoup potentially lost science. You've got to, in some cases, you've got to just bite the bullet, pardon the expression, and say that's it. We've lost it. So it's a real tragedy, and it moves on to our next story, which is another bit of a tragedy. Is as you were saying about Mark van der Heijden. Now, this story came out that, and it was almost considered to be a joke, but it's a joke in really, really bad taste, given all that's going on. So there's been lots of stories across multiple press associations and news outlets, etc., saying that the Russians were threatening to dump the ISS on North America, as you said. Even the London Times was focusing on that. Now, Van der Heijden is only one of three. There's three other astronauts up there that could be, in inverted commas, stranded. So he's not the only one up there. And as Terry said, it doesn't look like this is going to happen, but it was in a really, really bad taste. The joke, this is Aria Novosti, one of the Kremlin-aligned kind of outlets, as it were, one of the Kremlin mouthpieces, that put out a kind of spoof video saying that, this was going to happen. And then they said it was a joke. But as I said, really, really poor joke. And given Dmitry Rogozin's outbursts, and it's like watching a child have a meltdown in some respects. And I don't say that lightly, and I don't say it in a disrespectful manner. I'm just saying you only have to look at what he's saying, and you think, why are you doing this? You built up such an incredible reputation with Roscosmos for reliability, stability, fantastic cooperation and collaboration, and just because the Kremlin is saying you must jump, and he's saying how high. That's not how the world should be in the 21st century. I'm sorry, it really isn't. So NASA is saying currently that the ISS situation is okay, and the space will continue, and it is going on as we speak. But then on top of this, Van der Heijden was just one issue. We've then had this kind of very public spat between some quite notable people in, Scott Kelly. Scott and Mark Kelly, obviously both astronauts. Scott Kelly has flown multiple times on the ISS, twice on a Soyuz, and he's now saying that he wants to hand back his medals. And given that a lot of the astronauts, nearly all the astronauts that fly to the ISS, or pretty much these days, have to learn Russian as well, because obviously they're collaborating with their Russian colleagues up there, he was basically attacking via social media Dmitry Rogozin, because Rogozin's tweets were so, angsty and antagonistic and inflating the situation so badly. He just said, well, I've had enough of this. And his reputation and standing with the astronaut community is unparalleled pretty much in the modern era. He's extremely respected. And for him to say, right, well, I'm going to hand back my Medal of Merit, which was given to him by Dmitry Medvedev, who was the former president of Russia, that is a really strong statement, I think, in that he doesn't want anything to do with Rogozin. I think this is kind of leading on to what you were saying before, Terry, that I think NASA and ESA now have really got to consider, unless the whole structure of Roscosmos is changed and people like Rogozin are removed, and if Putin is removed, potentially we could have a perestroika type moment, hopefully with a good Russian leader who comes in and says, we've really got to rebuild this. We've really got to change how we think and how we move forward. I don't know if that's going to happen. But essentially, I mean, Rogozin was coming out with stuff like it's going to cost the West $8 billion to not deliver rocket engines and OneWeb satellites and $4 billion here. He was chucking around horrific numbers, then threatening, saying he's going to let the ISS fall out of the sky. He's not representing the vast majority of the Russian scientific community. That's the fact. And, do not want to turn this into some kind of Russia bashing thing. Russia is a beautiful country with an incredible history, and there's some great scientists. Let's not forget, Sergei Korolev was Ukrainian, was born in the Ukraine. Okay, it was former Soviet territory at the time, but the great designer, the people who kept Werner von Braun awake at night during the 60s, during the Apollo era, they've had some phenomenal people, and they still do have some phenomenal people. So we really don't want to see this fall apart. I mean, as I said, it could escalate into something far worse, and we all hope it never will. But yeah, and Kelly's comment, it was really quite heartrending in many respects. He said, I want to give you to give my medal to a Russian mother whose sons died in this unjust war. I mean, he wasn't mincing his words, Scott Kelly. And given, what's happened with his family and, Gary Giffords and, her being shot, etc., they don't want to see any kind of conflict and war in the world. None of the scientific community do. We all just want to see science. We want to see great science done. And you turn to the James Webb and some of the stories we're going to be coming on to, and you can see that great science can be done and great collaboration can be done. But anyway, that's just kind of my 5-minute rant on this.
I think the good news on that side is that on board the ISS itself, there appears to be no conflict between the Americans and the Russians. And another thing that's a good angle is that Scott Kelly is now retired. He's no longer a NASA astronaut. So what he's doing personally. So it's not as if the head of NASA was having a spat with the head of Roscosmos. That would be pretty bad.
Oh, but yeah, then we had Elon Musk wanting to go hand-to-hand combat with Vladimir Putin. I mean, it's almost getting silly. And Elon Musk is known for his kind of slightly off-center, off-kilt tweets on occasion. Bless him. I mean, it is a real love-hate relationship we've always had with Musk in terms of the brilliance of what he does with the Falcons versus some of his kind of more off-the-wall stuff in Starlink. So I don't know. But then Rogozin was saying that, America was going to launch on broomsticks. And then we had the whole SpaceX launch where they said, oh, we're going to send here's one of our broomsticks going up. It's all getting very silly. And a good friend of mine on Twitter today said, why is it that there's so many, ridiculous people? She used quite a like stronger language than that, but ridiculous people in the world. And it's true. Everybody just needs to step back and realize not just the damage to people's lives and the decimation of people's lives. And we're seeing millions of people leaving Ukraine now and going into Poland and various other countries around Europe. And it's heartbreaking to see that. But the impact is far greater than that alone. There are so many things that are just going to be. They're going to take decades to restore. We are back in. It's almost like we've rolled the clock back to 1961. The kind of time of the Cuban Missile Crisis and Khrushchev and Kennedy kind of era where, we don't want to go back there. So let's hope that sense will eventually prevail and that we're not glowing in the dark in a few weeks. And let's move on to a good story on Mars.
Yep, indeed, a good story. Very simple one, basically, but especially as it's Mars Week, it's worth noting that the Perseverance rover, Percy for short, has been trundling around Jezero crater on Mars, collecting rock samples, and it has now collected sample number 7. And everything seems now to be going well. There were problems earlier. You maybe remember we talked on an earlier show when some of the samples got stuck in the mechanism and they had to try and get them shaken out, which they eventually did. So they've now drilled a very nice, neat sample from another rock on the floor of the crater and stashed it safely on board. It'll be in a sealed container, and as I was alluding to earlier, that will be one of the samples that hopefully will be brought back to Earth at the end of the decade, early next decade, by the sort of the final part of this sequence of missions, the sample return mission. So nothing terribly exceptional about this, except that they're all different samples, different types of rocks. The thing about the Jezero crater is that it has an ancient river delta flowing into it, obviously caused by liquid water at some stage. So it's a prime site for the possibility of relics of ancient life. Very, very simple life, obviously. We're not going to find dinosaur bones or anything like that. So it's going to take one more sample in that area, and then it's going to be heading back more or less towards a space station, but going via the actual delta of the ancient river. And that's probably the most important site of all in terms of being able to find what may be samples with fossils of ancient Martian life. So Perseverance, good news. As I said, there were a few hiccups at the start. It's being guided by the amazing Ingenuity helicopter, which is a story in itself, of course. But it can get up and get a good view of what's ahead and say, right, there's something worth investigating over there. And assuming nothing goes wrong with the drilling and the sample collecting, there'll be quite a few dozen more samples altogether by the time this mission is ended. So that's number 7. Lucky, if you like, March the 7th in Mars Week. Well done to Perseverance.
Absolutely. And it's one of the missions, again, that it needs to be lauded. The descent EDL system on this was only the second time it'd ever been used, and again, absolutely nailed the landing. And it's been delivering fantastic science. The problem, as Terry just alluded to, is that there was a whole sequence of missions designed to collect these samples. Now, it's interesting. You're drilling core samples and then you're putting them in tubes. Obviously, because you don't want additional exposure to the Martian surface. If you're drilling into the rocks, you want to keep the samples pristine as possible, etc. And it will be the first time. I've got Martian meteorites behind me. Martian meteorites are not 10 a penny. They're not common, but we do have many examples, especially from the Allen Hills region. The most famous one, ALH 84001, which was discovered, and they thought initially there could be microscopic microbial life in it at one point. And you got Mars meteorites like Black Beauty, NWA 7034, etc., which are all really famous examples of great Martian meteorites that show evidence of this water kind of percolating through Mars in some point in its distant past. So it's not speculation. We've also got, as Terry said before, the Trace Gas Orbiter, which is looking at, along with some of the surface operations, looking at this methane issue, because that again is another big kind of weird one as to what the heck's creating the methane on Mars. We talked about that many times in the past, but I think this, and we'll move on now to the Ingenuity story as well. This, between the Mars samples and what this incredible little helicopter is doing. So this was it was designed as a kind of like a proof of concept, about a test thing that they were going to maybe fly 5 times over the course of a month. That was the whole thing. It says there it's at 19. It actually, as of today, is now up to 21 flights. It's incredible. This thing uses solar power, so it's got no consumables. So it's not like it's going to run out of power packs or energy, etc. And bearing in mind how thin the Martian atmosphere is relative to anywhere else, it's astonishing just to see it fly. And the fact that they've been taking high definition video of it taking off from the Mars surface pretty much since it started this about a year ago. It's incredible. And JPL have now said that, I think they said it's traveled 370 meters during its latest flight, which is 21st flight, 129 seconds. It's traveled nearly 5 kilometers since its first flight. 5 kilometers for a 1.8 kilogram helicopter that's tens of millions of miles away and is doing this autonomously, and is now providing real scientific input to the rover. So the idea was just to test it and to see if they could fly as a kind of, maybe for a future mission we'll put something bigger on the surface of Mars, or potentially if NASA goes back to Titan, with the European Space Agency obviously having the Huygens lander on the surface, if NASA and or ESA were to go back to Titan and go with a submarine, they had plans for what's called the Kraken submarine, to go into some of the methane lakes, but also to have a helo on a helicopter, helos as we call them in the defense sector, but helo on Mars and also on Titan, where the atmosphere is so much thicker. It'd be absolutely incredible. And this, as I said, it's a technology demo. This wasn't ever designed to be doing what it's doing a year later, but it's like everything that NASA seemed to do with the surface of Mars in the last few years. They said it was spirit and opportunity. Oh, we'll be lucky if we get a few months out of it. And then we go for best part of a decade plus. So they are extending the mission again, and it's now scouting ahead, as Terry said, into this river delta region. And this isn't just the NASA teams that are doing this. Kieran Hickman Lewis in the UK's Natural History Museum. So he's one of the scientists working on Perseverance, and he said at the conference that Ingenuity had basically been really helpful. I'm just quoting him here, in negotiating one of the regions called CITA, which is a region that's not optimal for rovers. And let's not beat about the bush. Spirit and Opportunity, we all know about sand traps and the issues that, those rovers have had in the past. We've seen the wheels, on many of the Mars rovers and how they're getting trashed. So this ability, even though they've got HiRISE in orbit, and HiRISE, the camera, the HiRISE camera is staggering. I mean, it's able to image the rovers from orbit quite easily. It's picked up a lot of the remnants of other missions like Beagle 2, etc., on the Mars surface. It's really invaluable having something that can literally just fly ahead saying, well, you've got this problem here, you've got this problem here, oh, that region there looks interesting, and then to use the various instruments that they've got on the rover to analyze the rocks is just amazing. It really is. And the other really, really cool thing about this is using what's called COTS technology. So this is common off-the-shelf technology that JPL have literally put together into a helicopter. This is not something that they've had to cook up from the ground up. They've literally used off-the-shelf components and parts. And that goes back to what I was saying before and alluded to before about the whole use of common technologies, integration that is a lot more streamlined and simpler for the future. And I really, really hope that this is not the only example of this kind of mission moving forward. I don't know what you think, Terry, but I just love it's such
Absolutely.
a great
yeah. I didn't think it would be possible, given the thinness of the atmosphere and the fact that it wouldn't have a decent power source to power really big blades, but they obviously did the calculations right, and it's working. See, there's a question there from Jamie about what sort of data Ingenuity is gathering apart from imagery. Because it's so light, it can just basically take photographs. It hasn't got spectroscopic or any other sort of analysis. But because it can take images from a whole lot of different angles, that's giving a sort of a 3D view. And the images themselves then can be analysed in considerable detail back here on Earth. But no, it's not taking any other actual scientific measurements, just the pictures. But the pictures are invaluable.
Yeah, absolutely. I mean, there's another comment there in the thread about the imagery and how it's able to kind of see behind some of the rocks as well. And, this ability to really get in-depth. I mean, don't forget, even with a mono camera, even not with stereoscopic cameras, you've got this ability, if you were to just alter your position by a few feet, to take stereo images and do compositing. And that kind of capability combined with, what it's able to do. And another comment from Robert in the thread as well about the recharge. You only have to look at, modern phone technology. And as I said, it's using COTS technology. How many recharges, how many cycles, who knows? They just said they're going to push it until it dies. I would imagine, if it's been going for a year now, and it's obviously going to be a trickle charge. You've got a relatively small solar panel, relatively lightweight, relatively small helicopter. It's going to need to charge up, and obviously it's got dust issues, like all of the rovers that have used solar panels in the past. Spirit and Opportunity in particular, where you look at the dust gathering, especially with dust storms, and then sometimes the dust storms will do you a favor and actually take the dust off. So large buildup of dust, you're going to not have non-optimal solar panels, but I would imagine, unless something fundamental breaks in it, I would imagine it'd probably be more like a gearing system, or maybe the gyros. Something could fail. A bit of dust could get clogged in there. That's more likely, I think, going to be a failure point for this. But we can just wish it well and just keep going. It's amazing. And watching the science team, especially during the depths of the pandemic. Don't forget, this was starting its mission then, and the science team all massed up in a room, visibly quite separated, just so excited about this. It's fantastic to see. So long may Ingenuity kind of keep going. Just to say to everyone who's in the chat thread, thank you so much. You've got some brilliant comments, brilliant questions. We love it. Just keep them coming. There's also comments about when we're going to see feet on Mars, boots on Mars. We've got to get boots back on the moon first. That's only 250,000 miles away. And, we were going to talk about Artemis and SLS and the cost of that, which, what the auditing office had come out with some astonishing numbers for the launch costs, which I've been having various arguments with people from Boeing and other very, very notable and very respected science commentators over the past week. And, anywhere between 2 and 4 billion per launch. Again, that model's got to change. That can't continue. When you're up against the likes of Elon Musk, you can't be charging or costing $2 to $4 billion for a launch on a non-reusable system. So anyway, moving on.
I'm just thinking what we need for Ingenuity there is some 7-year-old kid who's an expert on a joystick, and he'll turn the thing flat upside down, shake all the dust off, and then put it the right way up again. Anyway, on to another amazing universe story. my mind goes back to sort of the early days when I was in astronomy, and this was just, it hadn't even been thought of, basically, although theoretically the black hole was a possibility according to Einstein's theory of relativity. Now the things that we're discovering are just absolutely mind-blowing. The latest is a pair of two supermassive black holes orbiting each other, and they will eventually merge. They're so close together. Now, these are figures that will blow your mind. Each one of those black holes weighs 100 million times the mass of the sun. Our sun weighs 330,000 times as much as the Earth. And the Earth weighs, wait for it, 6 by 10 to the power of 24 kilograms. So if you multiply that back up, my mind just goes blank. I cannot conceive of anything that massive, but they're right there. It's just mind-blowing, basically. Now, they're quite close together in terms of their size and their mass and their orbital period and so on. But even so, the separation between them is between 200 and 2,000 astronomical units. Now, an astronomical unit is the mean distance between the Earth and the Sun, approximately 93 million miles or about 150 million kilometers. So these things are quite far apart. They haven't tied down the exact distance between them yet. But even at 200 astronomical units, that's well out beyond the orbit of Pluto in terms of the size of our solar system. You're right into sort of the outermost of the trans-Plutonian objects like Eris and so on. And it could be as much as 10 times as much as that. But in terms of the mass of these objects, that's relatively close. And they know for a fact that they are spiraling in towards each other and will eventually merge. Now, not in our lifetime or even their great-great-great-great-grandchildren's lifetime, but even that is a short time in the history of the universe. When that happens, you'll get absolutely amazing, major occurrence of gravitational waves. We'll not be around to measure them, but maybe our long-term successors in terms of some form of artificial intelligence or robots or something may be able to. So they're not anywhere near close to us. This is another interesting thing. They're 8.8 billion light years away. Okay, that means we're seeing them as they were 8.8 billion years ago. And an interesting angle is, how did some these black holes as massive as that form so relatively quickly after the birth of the universe, which is about 13.8 billion years. So that's about 5 billion years. We don't know exactly how these black holes form. They are in the center of really massive galaxies, but we think they can only grow to that size when a whole lot of different galaxies merge one after the other, and their black holes then merge as well. There doesn't really seem to have been enough time for that to happen unless it was in a very, very dense galaxy cluster where the galaxies were so close together that they kept bumping into each other and eventually merging. And that's a question for the cosmologists and the extragalactic astronomers, not for me. But it's just absolutely amazing. How did they discover this? Well, the interesting thing is that one of them is emitting a really massive superluminous jet, not superluminous, just subjet. In other words, it's traveling at almost the speed of light, material being ejected from it. And when they measured the variations in the brightness of that jet and the Doppler shift, they realized that one of the black holes, because we can't see them obviously, one of them was moving away from us, towards us, away from us, towards us. And from that Doppler shift of the light coming from not the black hole itself, but the accretion disk around it, they were able to work out that it was in an orbit with another supermassive black hole. So my take at the end of this is basically nothing in the universe should really surprise us anymore. Nick, what do you think?
Absolutely. And some comments. I've just noticed this as well. If you tip your head slightly to the kind of right, it looks like a barn owl, the image depiction, which is a good comment. I like that one. I mean, after watching Interstellar and looking at, some of the depictions of black holes, which have now proven to be accurate, it is amazing to see, again, the capabilities of astronomers to detect these things at these staggering distances. You talk about superluminous jets as well. What's interesting, given that we've got galaxy season not that far away, you look at things like Messier 87, which is quite a nice object if you're in the Northern Hemisphere to see. And even a small telescope can see the superluminal jet coming away from that, again, being generated, we believe, by a gigantic black hole in the core of this galaxy. And, our own galaxy, we now believe that there are supermassive black holes. I think once James Webb kind of goes fully operational, hopefully in the next few months, we're going to be rewriting some of what we currently believe. You alluded to that. It's like, how can this be happening? How can something of this scale have happened in a relatively short time frame between the formation of the universe at 13.81 billion light years ago, light years in the past, and then? And you think, well, I personally think, we stretched the Hubble almost to its limits in terms of what it's capable of seeing. Obviously, James Webb into the near infrared, far infrared, etc., is going to be able to see far bigger aperture. And, looking at redshifted objects, it's going to be far better at that. I think there's going to be some changes, Terry. I don't know what you think, Terry, but I think there's going to be some fundamental changes coming in the not too distant futures to what we believe in terms of galaxy formation, black hole formation, etc. We probably won't rewrite our belief on the Big Bang, but I think there's going to be some big changes in how we understand galaxy formation, etc. I think coming around. I don't know if that's your take on this as well.
Yeah, absolutely. And that's basically why the James Webb was designed to work in the infrared and the mid-infrared, where you can not only look back in terms of sort of seeing past the effect of the redshift of the expansion of the universe, but you're seeing back through the dust that lies in interstellar space and parts of galaxies and so on. So it will be able to see things that even if the Hubble Space Telescope was 3 or 4 times the size, it simply isn't looking in the right wavelength. So JWST is, assuming everything works, really going to give us incredibly new, valuable information about that very, very early period in the universe, which will be fascinating.
And the latest update on that is they're still collimating the mirrors. They're still obviously doing a lot of the scientific checkouts. They're testing the instrumentation now. The last mirror image that came through was stunning already. I mean, it's going to be incredible if it keeps going the rate it's going. Obviously, it's pretty much nearly out at its Lagrange point now. So hopefully in the next few weeks, we'll be covering what we would hope will be first light, as it were, and some of the first images. And don't expect the pillars of creation. We're not going to get that. It's an infrared telescope. The aperture is amazing. It's going to be far higher resolution than, for example, the European Space Agency's Herschel, which one editor at a space magazine described as the images look like somebody had kind of vomited on a plate. And that was his words, not mine. But James Webb is going to be delivering spectacular science, and that's the key thing here. So we'll be covering that, don't worry, as we move forward. Moving on to our second to last story. This one I've got, I really like this, principally because, and I'll just grab one here, I'm really into, as you can see behind me, meteorites. So this is some impactite in what's called a fin section slide. And I've got loads of meteorites behind me as well. We'll talk a bit more about that in a moment on our next story. But this is the re-evaluation of a crater. So this is the enormous Hiawatha crater. So Hiawatha, great name for a crater. This is 31 kilometers wide, and it's buried underneath the Hiawatha Glacier in northwest Greenland. Now, it's been known about for quite some time, and initially it was believed that it was tied in with far more recent events in terms of the climate change in the Great Ice Age period, 10 to 15,000 years ago, etc., etc. And it looks like now that's not actually the case, and it looks like that they kind of had to reevaluate this quite significantly. So one of the theories was that it was about 13,000 years ago that this impact crater had occurred. And as I said, 31 kilometers. If you put that into context, the crater at Arizona, the Barringer crater, the great famous Barringer crater in Arizona, is about a mile across, so about 1.7 kilometers across. This is massive. It now transpires, based upon analysis of some of the rocks, etc., and some lidar data, etc., that's been coming from this, that this event occurred 58 million years ago. So not long after the great KT boundary event, the great Chicxulub cratering event, which wiped out 76% of all life on this planet, aka the dinosaurs. dinosaurs and much more at the time. And this is scientists at the University of Copenhagen who've come up with this. It's amazing how you think you know something, and then you do more scientific exploration. And this is, a combination of space science, LiDAR, orbital analysis, on-the-ground analysis by geologists. So dating things like zircon crystals, which is one of the methods that they use. And basically looking at this data, it's incredible to think that this whole region at some point in the past was almost subtropical. That's the first point. And we're still trying to work out, going to the other side of the planet, the whole extent of the Antarctic kind of subcontinent is where beneath the ice shelf and what's there. And we keep finding hundreds of meteorites in that region. But to know that there's so many of these massive impact craters all over the Earth that kind of either keep revealing themselves for the first time, or when they do reveal themselves, the aging of them kind of all seems to tie in with these catastrophic events. I mean, a 31-kilometer wide crater is enormous. It's absolutely enormous. We're talking about something that potentially would have, if there was much life around, post-dinosaur epoch in that neck of the woods, it wasn't going to be around for much longer, because something that creates a 31-kilometer wide crater is going to have quite a devastating effect on any of the local fauna and flora. I don't know what you think thoughts are on this, Terry, but I thought this was a great kind of update of science again.
Yeah, absolutely. The angle on it that occurs to me is sort of both good and bad. And nobody wants to see the Greenland ice sheet melting because of the effects that'll have on rising sea level. But as the ice retreats and as it thins, actually, we'll be able to access any more of these craters that may well be there. And Greenland is a huge unexplored area of the Earth's surface. They didn't actually detect this crater directly. It was by basically bouncing signals off overflying aircraft and measuring the changes in the density and the depth of the echo. But as the ice retreats, we'll be able to actually get down at the crater itself, as opposed to just the samples that were blasted out from it. So, as I say, I don't want to see the Greenland ice sheet melt, but there are some minor benefits from it. So that's all I'm going to say on it. I get into deep water if I say any more.
This is the thing, is that with going back to what I was saying before, we're constantly finding stuff using greater science and greater and newer methodologies. And again, another really good comment is in the thread about the scientific method, and it's so true. We're refining our techniques, our technologies, our understanding all of the time, not just in space science, but in geology, in climate science and understanding. This is why science is so fundamentally important. If we didn't have science, we wouldn't be getting through, potentially getting through this pandemic in the way that we are. We're not out of the woods yet by any stretch. COVID cases are still going up, but thankfully, due to brilliant scientists, so many of us have been vaccinated, and we can start to continue to kind of progress with normal-ish lives. But this crater was only discovered 7 years ago, and to go from that to redating it and to getting such an accurate dating now that they believe, and again, it can change, but I just look forward to more and more of them. I think there's going to be so many discovered, and it'd be really interesting. One of the things I'm really keen to see if it did happen was with the Chicxulub event. Was it just a singular impact? Was it just the one impact in that region? Or was it, as happens with most meteorites, when an asteroid impacts the Earth, it breaks up as it's coming in. And obviously what happened in Chicxulub was an enormous impactor. But did you have additional objects that maybe struck even the next day, thousands of years, even hundreds of thousands of years later? We don't know. But it'd be fantastic to try to find out, and then using core drilling technologies that we've got now. They've core drilled into Chicxulub and got some amazing samples back from that, to be able to look at that and say, well, this event here was linked in with this event, and this event was linked in with this event. And it's fantastic, and this is why you got to love meteorites. It's the only way we can actually touch space, so it's fantastic.
Yeah.
Anyway.
Robert has actually asked an interesting question there about how many craters under the sea. And interestingly, Chicxulub is mainly under the sea. About 2/3 of that crater is actually under the Gulf of Mexico. And it's by echo sounding off the floor and determining the density and composition of the rocks and so on, that you can work out the pattern of the crater, because what there is above land is not all that easy to identify, because there's been erosion and so on, and vegetation ocean growing over. So you're absolutely right. There are ones under the sea, and I don't know, maybe you know the exact figure, but I'd say about 2/3 of that crater is actually under the sea in the Gulf of Mexico.
Absolutely, and the cenote holes. If you've ever been to Mexico, I've been to Mexico, and been diving in the cenote holes in the past. Swimming, not diving, but they're one of the indicators of what happened in that region with the kind of the collapse of that whole section of land, and the carving out by this gigantic asteroid or comet, depending on whose theory we believe this week. And as you said, most of it's under the ocean, and you've got all the silt covering, you've got the ocean covering, you've got, it's down several kilometers before you're drilling into what they saw with this incredible shattering. And you look at what they call impact heights. Rochechouart crater in France is a good example. Nordlinger Rise crater. There's so many all around the world where if you dig into the rocks and you see the catastrophe that has happened to these rock formations when something that large hits them, and you get, as I said, these beautiful impact height structures, and they're a really fascinating thing alongside meteorites. Meteorite is the thing from space, but the impact height, there's so much of it. I've got a friend who had a farmhouse in Rochechouart, and most of his farmhouse was built from impact height, was built from the impact remnants of the crater. So yes, Robert, you're absolutely right. There's who knows. There's going to be so many. The problem, it kind of is a bit of a sad story in that the Alvarez brothers, who basically, or father and son team, who worked on the Chicxulub crater. This is part of an oil and gas exploration that was happening at the time. Now, with the cutback in the use of fossil fuels. Are we going to have? Hopefully, science will take over, and we're just going to get scientific exploration of the deep undersea, as it were, and see what lies there. But obviously, we've got massive amounts of plate tectonics on the Earth. We've had, going from Pangaea hundreds of millions of years ago to the formation of the Atlantic, Pacific, etc. oceans, and everything shifting about. So, who knows with the oceans? Because obviously, you've got continuous evolution in the oceans with plate tectonics and subsumation and the Central Atlantic Rift, etc., kind of separating the two continents every year by a couple of inches or whatever. So, if there is evidence there, it's going to be really hard to find. And I think there's probably a better chance of looking in places like Australia and Russia. I mean, Russia, it's the largest landmass, by kind of area on Earth. There's going to be so many more craters. I mean, they've been hit 3 times in the last 110 years. So there's going to be a lot there. But very, very good question. Thanks, Robert. Our last story goes back to these bad boys. So that is a carbonaceous chondrite. We're wearing the carbonaceous chondrite t-shirts again, which contains all these organics. And Terry's going to tell us all about what's come back from Ryugu.
Right. Well, we're going from an object that weighed probably quadrillions of tons to one that's an awful lot smaller, the asteroid Ryugu. And in fact, the sample that we have got from it weighs only 5.4 grams. So it's from one extreme to the other. But yes, Ryugu is a fascinating asteroid. It was only discovered relatively recently, and the thing that's most interesting about it is that it's a very primitive material. It's a C1 chondrite type material, which we think is material that is more or less unchanged from the very start of the formation of the solar system. Unlike anything that we get on Earth, even if it's a meteorite coming from some object that's pretty old, it has been contaminated to a certain extent by the very act of landing here on the Earth. The samples that we have got back from this amazing mission, which I'm going to describe in a little more detail now, are absolutely pristine. So Ryugu is, as I say, a small asteroid about 900 meters or 2,900 feet in diameter. They think it formed outside what is called the snow line in the early solar system. In other words, outside the distance from the sun where liquid water would have been possible. So although there are signs of water in this sample, that must have been caused by a collision which broke it off. They think Ryugu was actually part of a larger asteroid. So the water that was evident in the samples, just tiny amounts, obviously, was caused by the impact, not by it being formed within the snow line, if you like, where liquid water is possible. So I'm getting a bit off track there. It's an interesting asteroid, spins on its axis every 7.6 hours, which is roundabout average for an asteroid of that size. And the Ryugu mission was the mission to Ryugu was the Japanese Haibasa 2 mission. Another one which is an amazing success story for modern science, to send a spacecraft out into the asteroid belt to rendezvous with an asteroid, to take an initial sample off the surface, then to fire a little impactor into the surface to disturb the material, and then go and collect some of that disturbed material which was below the surface, and to safely stow that on board, bring it back all the way to Earth and land it safely in the Australian desert and recover it. And all sealed and hermetically sealed, so they're completely uncontaminated until they get it into the laboratory. And although it's only 5.4 grams, with modern analytical tools, you can do an amazing amount of science on that. And I couldn't start to describe to you all the stuff that they found in that. But the interesting thing, as far as I'm concerned, is that they have found prebiotic material, not life, but the materials that go into forming life, amino acids and things like that. Things that go to build proteins and so on. So far they've discovered more than 10 different amino acids in that. And you needn't get into the biochemistry, but basically those are compounds that are essential for life. They've also discovered carbon and oxygen, nitrogen, and so on, and alines and other prebiotic material. So that lends a lot of support to a theory, which is sort of growing in popularity at the moment, is that life on Earth was actually brought to the Earth by the impact of either comets or asteroids, or both, rather than forming here on life ab initio, if you like. Now, the jury is still open. In fact, it could possibly be both. But the very fact that they've discovered this, what they call prebiotic material on an asteroid, certainly gives a lot of weight to that. And you're the meteorite man, Nick. This isn't a meteorite as such, but it's very similar to the C1 chondrites. So I'll let you comment on that as well.
No, it's fascinating. I've got a range of meteorites. One of them is called ZAG, which again contains a lot of these kind of organics and prebiotic materials. And then some meteorites contain even pre-solar grains, which outdate the solar system by several billion years. Obviously, the solar system formed from potentially a shock wave, which compressed a gas cloud, and then our sun formed, etc. Some, potentially 8 billion years ago. It's really, really interesting. And I'm holding in my hand, you talk about 5 grams. This is a 39 grams. So I don't know if you can kind of get an idea of the size. This is a 39 gram meteorite. This is Allende, which is probably one of the most studied meteorites in history. Fell in Allende, Mexico in 1969, and was used extensively for some of the kind of Apollo test procedures when they were looking at what they were going to do with the lunar sample return. This is a fascinating meteorite in its own kind of light, as it were, as a carbonaceous chondrite. But yeah, these C1 chondrites, and the fact that there's so much that we don't know, and we need more sample return missions. Now, if we're going to do more sample returns from, other asteroids, potentially looking at some of the larger asteroids, we've got examples on Earth of potentially impact meteorites that have come from Vesta, for example, the HED chondrites, Howardite, Eucrite, Diogenite chondrite series, which is really interesting. The more, the merrier, I say. And if we can ever find some kind of link that, the spark of life, see, it's one of the great mysteries of humanity, and one of the great scientific questions. The spark of life, where did it come from? Was it formed on the Earth? Was it a combination of a prebiotic soup and an electrical discharge from a cloud? Who knows? Nobody knows. But it'd be fascinating to think that the panspermia idea put forward by was it Chandra? Yeah, Chandra.
Wickramasinghe.
Yeah. Amazing idea, and the red rain kind of that happened a few decades ago, made famous by Peter Gabriel. it'd be really fascinating to think that life was deposited here from somewhere else in the universe, therefore meaning that potentially life does exist elsewhere in the universe. Going back to some of the comments, Ground-Based Space has just brought up that the Astra LV-009 rocket has been successful. I was watching that earlier on today via social media, and there were some issues. It went really quiet for a while in terms of post-fairing deployment and whether or not they'd actually deploy, but it looks like it's really a success. And again, that's a great bit of news, because it means that yet another launch provider is now online and delivering. And UK, we're in a Jubilee year with the Queen in the UK, and we're hoping to have the first UK launch, even though it's going to be Virgin Orbit and they're a US company. And massive, I just want to say this as well from a personal note, the team at Skyrora are based up in Scotland, and they are a great bunch of people, and they've got lots of kind of really great scientists and engineers working for them. But one of the main scientific kind of production facilities is in Dnipro in Ukraine, and their team are actually fighting now against the Russian army. And this is, Skyrora, a really well-known name in the UK space sector, developing a range of rockets. They're hoping to do vertical launch from Scotland, from some of the Scottish launch sites in the not too distant future. So a massive kind of, shout out to them and the immense bravery that they're showing. But yes, it's all power to space missions. That's what we want. And to our final look up brings us back to space missions. What are we looking out for this week, Terry?
Yeah, there's not an awful lot happening in the sky in terms of our own solar system, except one thing, which is instructive rather than impressive. But certainly in the meantime, starting on the 18th of March, the International Space Station will be visible again for a series of evening passes over the UK and Ireland. And go out and have a look up and think of the poor guy up there who's wondering whether he's going to get back down to Earth or not. I'm fairly sure he is. But interestingly, there are 3 Russians going to go up and join the crew there, I think in about a week's time. So they will then sort of be replacing the 3 that are due to come back down, which is the 2 Russians plus Van de Hey. So I don't think they can all stay up there for another 6 months. So some of them will have to come back down anyway. But it is fascinating to think that that huge big complex is going around there all the time, whether we can see it or not. 17 orbits per day, that's 17,500 miles per hour. And as far as we can tell, the astronauts and the cosmonauts up there are getting on with things. They're maybe not sort of as brotherly love, full of brotherly love as they might be, but they are putting any political differences aside and getting on with the science, and that's the way it should be.
I wonder if the German astronauts holding them apart.
Yeah. Right. We'll not go down that road in terms of peacekeeping. Anyway, the other thing that's fascinating, and you can't actually see it, but you can see the effects of it, is the equinox, the spring equinox, which occurs on March the 20th at 15:33 in the afternoon. Now, contrary to what you may read in various articles or on websites and so on, the sun does not appear to rise and set exactly due east and due west on that date, and that is because of the effect of refraction. Certainly in our near the equator it does, but in high northern or high southern latitudes, approximately where we are, that does not happen because the sun appears to rise at an angle. It goes across from below the horizon up like that. And the effect of refraction is that it raises the apparent position of the sun by at an extreme about a degree above the horizon. So instead of rising due east, the sun actually appears to rise a little bit north of east for us in our latitude in UK and Ireland. The same applies when when it's setting in the west. Now, if you have a very accurate compass on your smartphone, mine claims to be accurate to 1/10 of a degree. Whether it actually is or not, I don't know. But if you can go out on that date and measure the exact position on the horizon where you see the sun rising or setting, you will find, if your compass is accurate enough, that it is not exactly due east or due west. It's a bit north of that. The other interesting thing is that you might think at first sight that the equinox would be halfway between the winter solstice and the summer solstice, but it's not. And this is where the instructive bit comes in. The winter equinox, or the winter solstice, was on December the 21st, and that brings us up to the equinox on the 20th of March, which is 89 days. Now, my maths are not the best, but if you multiply 89 by 4, you get 256 days, not 365 days. So obviously, the gap between the winter solstice and the spring equinox is not a quarter of a year. It's less than a quarter of a year, considerably so. And you might ask, why is that? And the reason is very simple. It's because the Earth is at its perihelion closest to the sun in early January. And that means that at this time of year, it is moving fastest relative to the whole of its orbit. Kepler's laws of planetary motion. Basically, the closer you are to the sun, the faster you have to move to fall into it. And Einstein would kill me for saying something as simple as that, but we'll ignore that. That'll do for our purposes. So at this time of the year, the Earth is actually moving faster than it is during the summer months when it's at its furthest away from the sun. So it has moved faster to reach the equinox from the winter solstice up to the equinox than it will do when it's moving from the equinox to the summer solstice. So that tells you quite instructively and quite easy to understand just the effects of the variation in the speed of the Earth in its orbit due to Kepler's laws of planetary motion. Right, Nick?
Interesting. It kind of brings me back to university days and general relativity, and the fact that gravity is not a force, and it's just, the whole you're falling, and it's inertial reference frames, etc. It's like, yeah, it's true. It is fascinating. In terms of what's happening with the ISS, we've just got to hope that it continues, and the professionalism, the consummate professionalism of the astronauts and the cosmonauts on board does continue. I mean, that's what we want to see in terms of what's happening up there. Right now, we are approaching, as I said, galaxy season in the not too distant future. I mean, as Terry said, we're spring equinox, so the clocks are going to be going forward. No, forward, isn't it? I say back. Always get that mixed up. Yeah, spring forward, fall back. Yeah. So the clocks are going to be going forward. Lighter nights are coming in. It's a boo time for astronomers. We always hate the summertime unless you've got a hydrogen alpha or calcium K-line telescope and you can look at the sun, which is a lot more active these days, which is another interesting thing that's going to impact satellites over the coming years. It's that time, though. I think it's one of my favourite times of the year in terms of observing coming up with the galaxies and what's the whole Virgo cluster and looking at a kind of Markarian's chain and that whole string of fantastic galaxies that you can see. So if you did get a telescope for Christmas, and we keep promising we're going to do an episode on this, and we should, I think we should probably plumb that in for the next one. Like a kind of back to basics, as it were. We'll do a little bit of news, but we might do a kind of bit of a back to basics on, so you got a telescope for Christmas, what are you going to do with it, kind of thing. Hopefully we can do that as part of the show anyway. It's been a traumatic few weeks for most of Western Europe in particular, and as Terry said many times, our heart really does go out to everyone in Ukraine, not just the scientific community, to everybody. I mean, we don't need this in the world right now. We've just come through 2 awful years of a pandemic. The last thing we needed was this really messing things up. Let's hope sanity does prevail. Let's hope that we continue to be able to bring you some fun science news, and it won't always be dominated by some of the horror stories that we're hearing. Again, a massive shout out and a big thank you to our friends at Space Store, who, again, they just keep marching from strength to strength. They're doing great STEM work, as I said, partnering up with Razor, doing phenomenal work almost on a day-to-day basis. If you're ever in the Didcot area near to the Harwell Space Campus, which is a massive campus and growing almost daily, it's worth a pop in. Just as I said, I love going there because their coffee's so good, as well as the space experience. But if you've got kids, it's a great place to go. I'll hand you back now, probably to Latch if he's available. Yeah, he's there. It is fantastic. He's got a beanie hat on there, Latch.
Yeah,
Nice one.
I do.
Nice one. But yeah, massive thank you as ever to what a great team behind the scenes and to everyone in the audience as well. The last few weeks, seeing so many chat thread comments, etc., it makes it really worthwhile for us. It really is, because it takes us in new directions. It asks us really interesting questions that we may not have thought of, and most of the time we haven't thought of. So huge thank you to everyone. There's so many names that, it's a big list in the chat thread tonight. So thank you for that. We're broadcasting on Twitter, Facebook, lots of different social media platforms. So just keep enjoying the show, hopefully.
Could I leave you with one thought? Think
Yes.
of the blue marble
Yeah.
as imaged by Apollo, came around the moon. We're just one planet. And even further from the Voyager image from, or it was Voyager, I think, the pale blue dot, 1 pixel when you photograph the Earth out from beyond Saturn. That is us all on the one planet. We have to learn to live together.
Yeah, absolutely.
That's really well said. Really well said, Terry.
Okay. Cheers, everybody.
Awesome. Thank you once again for another great show. It's been great. Thanks everyone in the chat. Thanks Robert, Chris, Ground-Based Space, and everyone else.
So many. There's loads.
There's quite a few people in the chat I see tonight.
It's
great
brilliant.
to have you guys. Just one final plug from me. Nick mentioned it at the start, is Razer. As you guys know, it's Mars Week this week, and our friends at Asteroid have been providing some great educational content based around Mars. And Space Store partnered with Razer, which is one of the projects I'm quite heavily involved with on a daily basis, to provide some really fun, cool, interactive digital activities. So if you want to check those out, the URL's on the screen. Have a go. Give it to your children as kind of a homework evening activity if you want. Check it out. There's some cool videos on there, and hopefully you guys enjoy that.
Yeah, Asteroid do great stuff as well. I mean, knowing people like Joe Richardson, etc. It's the European Space Agency's kind of one of their main outreach arms, and they do really, really great stuff. So again, huge kudos to them. And get back to Space Store again, huge kudos to you, because I know so much of your focus is on STEM and outreach. So and that's what we're trying to do as part of this team. So thank you.
Awesome.
Yep.
All right.
I echo that.
Have a great evening, and we'll see you in a couple of weeks. Same time, same place on the 29th of March.
Thanks, everybody.
Adios.
Okay, guys.
Stay safe.
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Mosley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Store. Adios, amigos.
Bye, all.